Hi, I'm Abel Broomfield, and this is Project 3. So this time we're going to be using Python and PSOC to get the manipulator to move at a certain degrees. So here's the manipulator right here. So basically all I added was this end. It's not an end effector, but I'm going to call it the end effector. But we added this end that holds the pen holder for the marker. And it's going to go in like this. It's going to draw points whenever we program it into the PSOC. So using the old PSOC we had, we're going to add more to that and take away from it as well. So show you. Currently on the board, I drew a Y and an X axis to show the points, and also we're going to be able, once we program, we're going to be able to tell the calculations are accurate by the movements. So let's get started. So here we have PSOC, and we use the same exact PSOC from Project 1. The design is still the same with servo 7 and 6, and the top design is still the same using the same PWM. So now we just have to leave the main C. So the only thing we changed in main C, we left theta, we left theta 2, theta 1, we left its main void, we left PWM 1 start. For the for loop, we shortened it. So we made the PWM right compare, we changed that and made all of those comments. We just added another right compare 2. We added right compare 1 and right compare 2 and changed it for theta 1, theta 2, and the set degrees we 1 and 2. So we're going to start off with 45 degrees for both angles, and we did a delay of 2 seconds. So let's see how that moves. To the Arduino and everything. So we need jumper wires to breadboard, the Arduino and its USB cord, and we might need an extra cord in order to send more power to the Arduino. But we'll get to that when we get there. So now we're gonna set it up like we did. Red is gonna go to red. We're gonna use green for ground, and we're gonna use orange for the white, and that's gonna go to P7, P6. So do the same for the other one. Red, green, orange. So here, let's plug it all in. Positive. So here's the Arduino. So now I'm gonna program the Arduino to the I'm gonna program the Arduino from the computer to this microcontroller. So let's build it first to make sure the build is clean and successful. So we got successful build, and let's program. We got successful program. So now let's plug up everything. So we're gonna plug in ground. So I'm not gonna plug in the VDD yet because the microcontroller is going to move. The manipulator is going to move. So we don't want that right now. We want to wait so that it won't jump. We can actually get it to show how it moves. So let's take the top off the marker. Okay, so let's plug in and show you kind of how it looks. So this is the angle that it drew. Okay, once I plug in everything, we're going to get the line to move. So see, and it moved from the points. So this one 45 degrees and this one 45. So now let's program it to go 60 and 75. So this is when we programmed it at 60. And it goes, both angles go, this goes to 60 and this goes to 60 as well. So now we're going to do 75. So now let's do 75. So it went past my white mark because both angles are set to 75. If one angle was set to another degree and this degree, I would have been able to stop it before it went to the past the 90-degree angle. But it went past it, so that's why, because both angles are set to 75. So now we can use Python to calculate everything. Just as we did in project 1, we can do this again in project 3 to calculate and make sure that what we did using the PSOC can come out accurate using Python. So let's start. So we measured each manipulator and servo motor with the ruler and centimeters. So from top to bottom, servo 1 was 5. From link center to the rest of the link, it was 6. And then top from bottom was 5.5. And then it was 5.5 again for the links. So as we started off, we used 45 degrees for each angle. We did T1 and T2 divided by 0.80, which made this in radians. These are the matrices that we use for each degree. So rotation matrix from 1 to 0 and rotation matrix from 2 to 1. This is what we got. And we did the full rotation matrix times each other using the NP dot dot. And we can print the matrices out using print NP matrix. So then we did the displacement, which is the 2 dimensions right here, using the displacement 1 to 0 and displacement 2 to 1. And then we did a homogeneous matrix using NP concatenate. So using that, we were able to multiply rotation matrix 1 to 0 and displacement 1 to 0. Well, not multiply, combined, and then combine homogeneous matrix 1 to 0 using what we got from the first one. So with 1 and 0 is very peculiar and very particular. So with how it multiplies. So 2 to 0 multiplies So then we moved on and did it from 2 to homogeneous matrix from 2 to 1 as well, and the same process. So then we use the print to print out those answers. So let me have it and run this module. So here we have the matrix, the homogeneous matrix right here. And what we got when we did the displacement for 45 is 9.7 and 4.2. These are numbers that are important. So then when we did 60 for both, run module again, we had 0 and 9. So then when we changed it to 75, we got -3 and 8 because it went past my 90 mark. So these are the numbers we have when we multiplied the matrix. Well, when we combined the matrices and multiplied the rotation matrix and the displacements, and we got everything that we need. So this is the matrix for 60, well, for 45, 60, and 75.